Everyone, this video is about the second part of the echoes lesson in the sound and light scheme of work. This might not be for all of your students because it involves ideas around speed, distance and time, which we haven't really taught yet officially. But if you've got a high prior attaining group and you want to do some stretch and challenge with them, I think these are quite fun calculations for them to do. But they do take quite a lot of thinking about. So again, what I would say is, yeah, choose carefully, be judicious about whether you decide to do this with your group. So what we've got here is just an example, and we in the first part of the lesson, and there's another video about this, you kind of talk through how this works, how ships do ocean detection. But it says what happens is a ship sends out a pulse from the bottom of the vessel, and it takes 0.8 seconds for it to be received again. So what you can do is sketch out to students and show where these ultrasound waves go. So they go down to the bottom of the ocean and then they come back to be detected again. And you can show this something like this. So they go down and then back up again. And the total time, you might add here, total time is equal to 0.8 seconds. And it also tells you that the speed of sound, ultrasound in water is 1600 meters per second. And what you need to do when you're modeling this is just really draw attention, because you'll see in the next example it's slightly different, really draw students' attention to the fact that this is the total time for the wave to go, or the waves to go all the way down and then all the way back. Because what that means is, and if I find a different coloured pen here, where's my red pen? It's gone. I'll use this blue pen. What that means is, and you can either model this and explain it to students, or you could question them, depending on the group that you have. But if it takes 0.8 in total, that means it takes half that time to get down there and half that time to get back. So what we can write here is the distance from the ship to the sea floor is just 0.4 seconds. And, sorry, the time taken for the sound to get from the ship to the seafloor is 0.4 seconds, and the time taken for it to get back is 0.4 seconds, because 0.4 plus 0.4 equals that total of 0.8. Now, again, you may be tempted to just dive into the equation here and do some algebra, speed equals distance over time, and rearrange whatever. Actually, I think quite a nice way of laying out these calculations, especially for Key Stage 3, is to really interrogate what's meant by this thing here. So if you've got a speed of 1600 meters per second, what that means is the sound waves travel 1600 meters in 1.0 seconds. That's what this means. So in a second, that's how far the sound waves travel, 1600 meters. Now what you're trying to work out is, well, okay, what's this distance here? And it might be worth, maybe I should have done this before, but what you're interested in is, well, what's this distance? I can put d equals question mark here. So you know the sound waves are going to travel that far if they're going for 1 second. So what you can write underneath here is sound waves travel, and I'm going to leave a blank here, certain number of meters, I'll put meters here, and in this case we've got 0.4 seconds, so I might write 0.4 seconds. So then we want to ask students, well, okay, if I've times this by 0.4 times 0.4, well, what am I going to have to do to this number to work out how far it's going to travel in 0.4 seconds? Well, hopefully they'll spot, and I say hopefully, oh sorry, not by 0.4 seconds, just by 0.4. Actually, students tend to have a pretty good intuitive grasp of proportionality, but it's worth going through this stage, because this is what we actually mean by the speed equals distance over time. And I think this illustrates quite nicely, this is similar to how they do it in maths, this illustrates quite nicely that idea of proportionality. So we've times 1 by 0.4 to tell us how many seconds this is, so we're going to have to times 1600 by 0.4 to work out how many meters it's going to travel. And again, I always like to get my calculator out so students don't feel like they've got to be super super brilliant at mental arithmetic. I'm going to do 1600 times 0.4 to equal to 640. So I'm going to write that in 640 meters in 0.4 seconds. And then what you can do is, and again we're going through this kind of in quite a long-winded fashion because it is year 7 that we're teaching this to, probably. So I might say distance from ship to ocean floor equals 640 meters. Now, really, the part here that relates to echoes is not all this stuff. This is kind of just jumping ahead. Again, I'd probably only do this if you've got a high priority group, because this is going on something that I'll cover in more detail in year 8. But the part to do with echoes is understanding that if there's a total time of 0.8, then the time for each part going down and then coming back is 0.4. And that's why this next example is quite a good test of whether they really understand what's going on or not, because what you get in this example, and you'll see this is the second one in the slides, is what it says is, you know, we've got the same system here. So we've got this sound wave being sent down to the ocean floor, and it's coming back. We know that the speed of the ultrasound wave is 1600 meters per second. And if you give this to students, lots of them will do the same thing, and they'll start halving the time that they're given. But if they read it carefully, what they'll see is it says the time it takes to get from the submarine to the ocean floor is 0.25 seconds. So you can put here time equals 0.25 seconds. I've not left myself enough room there. And it's really important that they spot that, and that's where all the physics is. Can they draw the diagram correctly? Because if they're rushing through, then they'll just use exactly the same method, but that's not the information that they've been given. And then you can do exactly the same thing here. So you can say sound waves travel, and I think it's worth writing this out to really get them to understand what proportionality actually is, so they're not just like randomly multiplying and dividing numbers. Sound waves travel 1600 meters in 1.0 seconds. Therefore, sound waves are going to travel a certain number, an unknown number of meters in, what have we got here? 0.25 seconds. What have we done here? You could say times 0.25. You could even say divide by 4. It's up to you how you lay that out. They might find it easier though to say divide by 4. So what we're going to have to do here, what we're also going to have to divide by 4. And again, I'll do this in my calculator just to show students that yeah, science questions are not about showing off your mental arithmetic, but what I get is 400. Okay, so I'm going to write 400 meters in 0.25 seconds. So then again, I can say distance from sub to floor equals 400 meters. So that's how I would model those out to students. Now they then get a few further examples to have a look at. What I would encourage them to do is go through that whole process, because if they're really taking their time to write out all of this stuff and think about it proportionally rather than just, you know, multiplying and hoping for the best, they've got a much better chance of actually understanding the concepts than if they're just bunging numbers into an equation and not really knowing what those terms actually mean. So that is the end of sound waves. In the next lesson, we'll be moving on to ray diagrams.